All right, 7.29 says the switch in the circuit has been in position 1 for a long time before moving to position 2 at time equals 0. Find I naught t I naught for t greater than 0. Okay, so time less than 0. Right. And we're going to find current I naught. So there's no KCL, there's just one current going across. So there's EFCs. So we're going to have let me draw my nodes. V1, V2. So I naught is equal to 15 minus V1 over 4700. V1 minus V2 is equal to 5 I naught. And then I naught is equal to 2 microfarad times dV2 over dt. So we're just going to plug in maxima. 3 equations. We have 3 variables. So I naught equals 15 minus V1 over 4700. V1 minus V2 equals 5 times I naught. I naught equals 2 times 10 to the negative 6. I'm going to call dV2 dTs. So we have I naught, V1, and V2. Okay. I might have made a mistake. I didn't assume that. Well, there's no I naught here. Sorry. I got carried away. Yeah. So this is one thing I forgot. I almost forgot. Capacitor acts as an open circuit over time. Yeah. So I naught is equal to 0. So there we go. Where not gonna go. Okay. So yeah, 3 equations. I naught equals 0. I naught equals 15 minus V1 over 4700. And then V1 minus V2 equals 5 times I naught. I naught V1 V2. Cool. So there we go. Right. Okay. So I'm glad I put this here. Okay. Yeah. So these are our values before. And now we're going to look for our values after. So this is going to close. It's going to disconnect. So it's going to appear. It's going to be an opening here. It's canceled out. All right, so let's go ahead and label. I'm going to call this my ground still. It's going to be V1 and then V2. Right. Okay, so then KCL is still the same. So our equation for components. I naught is equal to 0 minus V1 over 15. V1 minus V2 equals 5 I naught. And then I naught is going to be equal to 2e to the negative 6 dv2 over dt, right? So yeah, let's plug this into maxima again. See. So I naught equals negative v1 over 15. v1 minus v2 equals 5 times I naught equals 2 times 10 to negative 6 times s I naught v1 v2. So it spits out something different. Cool. So it's asking us for find I naught for t greater than 0, right? So yeah. Let's see. Yeah. So we should approach this with v2 because our equation wouldn't look right if we approached it with I naught immediately. We'd have something that would look different than this. We'd have a negative dyt over dt plus it just wouldn't make sense. Here, how would I explain this better? So it says, yeah, find t, yeah. Yeah, let's go with v2. We generally want to have a negative here. Gives us a good indicator. So I'm gonna rewrite our equation. So it's dy dt plus yt over tau equals k. Through v2, we're gonna find I naught. So, well, we can't use I naught. Yeah. So I naught, since we say this is our S, it wouldn't make sense for us to go ahead and plug dv2 into here. So this here would be the most appropriate to, okay, so 2,500 or 25,000, sorry, equals negative dv2t t dv2 dt plus 2,500 or 25,000, sorry, times v2 equals 0. We know that tau here would be 1 over 25,000, correct? And yeah, so then we go to our next equation, which is yt equals y infinity plus y0 minus y infinity times exponent e to the negative t over tau. So then use v2 here, right? So our voltage across our capacitor just dissipates over a long period of time. So 0 plus what's our initial before is 15. Our voltage v2 15 0 minus 0 e to the negative t over 1 over 25,000, which is 15 e to the negative 25,000 t. Right. Okay, so how do we calculate I naught then? So we want to find so we follow Ohm's law, right? So Ohm's law says V equals IR. If we want to find I, so we want to find V over R. So then we have to find the resistance value for this dependent voltage source, right? So this dependent voltage source says it's 5 I naught, correct? So this is our V. So V equals sorry, R equals V over I, and we know that V right here, V equals 5 times I naught, and our I is I naught. Our resistance here is 5 ohms. So our 5 ohms, sorry, here. So our 5 ohms is in series with 15 ohms. So our R equivalent is 5 plus 15, so 20 ohms. So then we can go ahead and this value, V, you can say I naught. I should make this. So know that I naught T equals to 15e to negative, sorry, yeah, 25,000 T over 20. So then this here would be our value. This here would be, this would answer the question. This would be our I naught for T greater than 0. And yeah.